Hello and welcome back. So our first section of the new semester is all about exponents. So this is something you've definitely seen in Math 1 and in Math 8. So hopefully it looks familiar. So the first thing we're going to talk about is when I multiply two numbers that have the same base. So just so we're all on the same page, this 2 is the base. And then 1 over here is the exponent. So I got a base and an exponent. So if they have the same base, 2 to the 1 is 2 to the 2, and 2 to the 1 is 2. So 2 times 2, that's 2 to the power of 2. 2 squared, that's 2 times 2. So again, exponent just means I'm multiplying the base times itself that many times. And then 2 squared is 2 times 2. So how many 2's do we have? 1, 2, 3, 4. So 2 to the 4th. 2 to the 3rd, that means 2 times itself 3 times, times 2 to the 1, so that means 2 one time. So I have 1, 2, 3, 4 2's, so that's 2 to the 4th. 2 to the 4th means 4 2's, all multiplied together, times 2 more 2's. So in total, we have 1, 2, 3, 4, 5, 6, so 2 to the 6th. And then 2 to the 3rd times 2 to the 3rd, 2 times 2 times 2, 2 times 2 times 2. So again, we have 6 2's, so 2 to the 6th. So notice that I don't multiply these 2's together, so I don't have 4 to the 6th. It's just the base stays the same, and then I add the exponents. So 2 to the 6th. So that's what this product of powers property is saying. When we multiply two numbers that have the same base, we add their exponents. So in example 1, 3 to the 2nd times 3 to the 5th, that's the same as saying we have 3 times 3, and then times 3 times 3 times 3 times 3 times 3. So then we have altogether 1, 2, 3, 4, 5, 6, 7. So 3 to the 7th. So instead of writing this out every single time, the little shortcut would just be to add the two exponents, the 3 to the 7th. So over here, now we have a couple different bases. So we always need to make sure that we only multiply like terms together. So what I like to do, you don't have to do this, but what I like to do is put the like terms together. So I have 2 to the 4th, so I'll look for the other base of 2, so 2 to the negative 2nd. Then we got 3 to the 4th and 3 to the 2nd. So we're still multiplying them all together, but now it's just easier to see which two go together. So 2 to the 4th and 2 to the negative 2nd. So if I combine the exponents, 4 minus 2, or 4 plus negative 2 would be 2. So 2 to the 2, and then 4 plus 2 is 6, so times 3 to the 6th. I'm just going to leave it like that. In example 2, so again, same thing. We want to make sure that we keep our like terms together. So if we have numbers, those are like terms. So I'm going to put those first. So these parentheses don't really do anything. All these parentheses are saying is that we're multiplying these two things together. There's nothing on the outside of the parentheses. So it's basically just telling us that we're multiplying. So 4 times negative 3. And then I'll do the x. So x to the 5th, x to the 2nd. So then I can just multiply from left to right. So 4 times negative 3 is negative 12. X to the 5th times x squared. So again, if we have the same base and we're multiplying them, we add the exponents. So that would be x to the 7th. So the same thing on this one. Again, there's nothing on the outside of the parentheses, so that just means we're multiplying. So I'm going to have m squared, and I like to put the like terms together, times m, and then n times n to the 4th. So again, I'm still multiplying all these together, but now they're in a better order. So m to the 3rd, because remember, if we just have m, there's an imaginary 1 there. Same with this n. So if I add 2 plus 1, I get 3. n to the 1 or times n to the 4th would be n to the 5th. And then in example 3, so again, I always do numbers first. So -3, there's nothing on the outside of the parentheses. So that would change the way we do this if there was. -3 times -2, and then I'll just go in alphabetical order. So I have an x times x to the 3rd times y to the 3rd times y. So now I'm just going to multiply from left to right. So -3 times -2 is 6. X times x to the 3rd. So remember, it's just an x. That means there's an imaginary 1 up there. So that's x to the 1 times x to the 3rd is x to the 4th. Y to the 3rd times y to the 1 is y to the 4th. And that would be our answer. All right, so this time we have a plus sign. So that means we're going to remember order of operations, so PEMDAS. You don't have to write this down if you can remember it. But parentheses, exponents, multiplication, division, and then addition, subtraction comes last. So I got to multiply first, and then we will add. So I got a -2 times a 4, and then a y times a y to the 3rd. So everything that's separated by this by this addition sign, I'm going to do together. So these terms I'm going to put together, and then these terms. So I'm going to put that plus sign here. So then I have a 3 and a -6. So we could even put these in parentheses if we wanted. And then y squared times y squared. So -2 times 4 is -8. Y times y to the 3rd is y to the 4th. Still have that plus sign there. 3 times -6 is -18. And then y squared times y squared is y to the 4th. So notice that we have some more like terms. We got a y to the 4th and a y to the 4th. So that means those are like terms, so we can combine them. So I have -8 y to the 4th plus -18 y to the 4th. So when I combine those, I get -26 y to the 4th. So moving on to the next page, example 4. So more of the same thing. This time we have a ton of terms that we're multiplying. There's no addition sign in here at all. So I'm going to multiply all those numbers together first. So -2 times 5 times 3 times -7. Then I'll do the alphabetical order. So x squared, and then I'll start with all the y's. So times y to the -2, and times y squared. So now I can multiply all those numbers together. -2 times 5 is -10, times 3 is -30, times -7 would be 210 positive. X squared, there's no other x, so it's just going to stay x squared. So I got a y to the 1, -2, a y to the -2, and y to the 2. If I add up all these exponents, 1 plus -2 is -1, plus 2 is +1. So I'll just have y to the 1 or just y. So again, same thing over here. So again, nothing on the outside of the exponents. That's actually going to be tomorrow's lesson, I believe. So I'm going to multiply all the numbers together first. So 5, 4, -3, times -6. I'm going to take the letters in alphabetical order. So a to the -3rd, a to the 4th. And then I got a b to the 3rd and a b to the 2nd. So I used all these terms in here. So now I'm going to multiply from left to right. So 5 times 4 is 20. 20 times -3 is -60. -60 times -6 would be 360. a to the -3 times a to the 4. If I add these two exponents, I get 1. So a to the 1 or just a. And then b to the 3 times b to the 2 would be b to the 5th. So 360 ab to the 5th. So now moving on to fractional powers. So a lot of times we might see fractions in an exponent. So the top of the fraction is the exponent. The bottom is the root. So a while back, or last semester, we talked about square roots. So whenever you see a 2 on the bottom, if the root is 2, that's a square root. So that meant we were looking for 2 of the same number inside of the radical. So you probably don't remember, but at the very beginning of the year I said there's always an imaginary 2 when you're doing square roots out there. That means you're looking for 2 of the same number in here. If this number turns into a 3, that means you're looking for 3 of the same number. So I'll explain it more when we go into example 5. So 4 to the 1/2. That's like saying 4 to the 1 to the root of 2. So that means 4 to the 1 is just 4. But I'm looking for 2 of the same number in here. So if I break down 4, I know 2 times 2 is 4. So right away we have 2 of the same number. One goes away, the other one comes out. There's nothing left inside of the radical sign, so I don't write the radical sign anymore. My answer is just whatever came out, which is 2 in this case. So the next one on example 5 is 27 to the 1/3. So that's like saying the cube root, or the third root, of 27 to the 1. So this number is the exponent on the inside. This is the root on the outside. This 3 tells us that we're looking for 3 of the same number in here. So if I broke down 27, 27 to the 1 is 27, of course. I know that 9 times 3 is 27. I also know that 3 times 3 is 9. So again, this 3 tells us that we're looking for 3 of the same number. Notice we have 3 of the same number here. So this time 2 of those go away and 1 comes out. So whenever we are looking for 3 of a number or 4 of a number or 2 of a number, only 1 will come out. All the rest will go away. So there's nothing left inside of the radical, so I do not write the radical sign. My answer is just whatever came out, which in this case was 3. The example 6, so we got 8 to the 1/2. So that's like saying this square root, or the second root of 8 to the 1. So I'm looking for 2 of the same number. So 4 times 2 is 8. 2 times 2 is 4. So I got 2 2's. One goes away, the other one comes out. And I still have that 2 left on the inside. So a 2 will be on the outside, and then 2 stays on the inside. And then 4 to the 3/2. So again, the bottom is the root, so that's the number on the outside. This is the exponent, which will go on the inside, so 4 to the 3. So I could do 4 to the 3rd, which would be 64. And I could break that down. So I could do 2 and then 64. I know that 8 times 8 is 64. So one of those 8's goes away, the other one comes out, so my answer would be 8. Or we could do it like this. So I'll just take 4 to the 3rd, and I'll just focus on this 4 here. So I know that 2 numbers that multiplied equal 4 are 2 and 2. 2 times 2 still has the 3 in the exponent, but I got a pair right here. So 1, 2 goes away, the other one comes out. Nothing's left on the inside, so I just write whatever comes out. So 2 to the 3rd will come on the outside, but 2 to the 3rd is 8. So either way, we get 8 as our answer. 2 different ways to do that. And then finally, example 7, I'm going to go quick because I know these have been some long notes. So we have 9 to the 5th, taking the square root of that. So 9 to the 5th means that I have 9 times 9 times 9 times 9 times 9. So I got a pair of 9's, pair of 9's. One goes away, the other one comes out. One goes away, the other one comes out. So 2 9's have come out. 1 9 is stuck inside. So 9 times 9 is 81 to the square root of 9. or times the square root of 9. But I know that 9 is 3 times 3. So I got a pair of 3's in there. So one goes away, the other one comes out. Nothing is left, so I don't write the radical sign anymore. So 81 times 3 now, which would be 243. And then finally the last one, I got 64 to the 5th to the 3rd root. So this is like saying we got the 3rd root of 64 times 64 times 64 times 64 times 64. So I'm looking for 3 of the same numbers. I got 3 64s. 2 of those go away, 1 comes out. So now I have 64 times 64 inside of the cube root, and then 64 on the outside. But I know that 8 times 8 is 64. So 8 times 8 is 64, and then 8 times 8 is 64. So I got 3 8s. 2 of those go away, 1 comes out. So 64 times 8. We still have an 8 inside. But I know that 8 is the same as 2 times 2 times 2. So I got 3 2's. 2 go away, 1 comes out, so I'll end up with 64 times 8 times 2, nothing left on the inside, so 64 times 8 times 2, and you get 1024. And that's it for the notes.